everybody, it's Max with Crypto Talk now. When it comes to Hedera's Hbar, I've been becoming more and more impressed with trying to understand, or at least taking a deep dive of my own when it comes to Hashgraph. See, here's the thing. There's different categories when it comes to DLT. So what does Hashgraph mean? Why is it important? And if anything, I'm going to finally answer the question I've been getting a lot lately from you guys, and that is just what exactly is Hashgraph and how does it work? Well, let's go ahead and break it down for you guys in this particular video. So let's jump right into it. If anything, I'm going to show you this. I'm going to blow this up for you and check it out for yourself. It says there's 5 types of distributed ledger technologies. Now, of course, you guys know I love to talk about the likes of Quant and, of course, what they bring to the table when it comes to DLT. But Hedera's Hbar brings its own element, and that is Hashgraph. So that is actually part of 5 different types of DLT technologies, right? And I'm going to jump right to the specifics. You know, as we know, there's categories of distributed ledgers. You're going to see, for instance, these mentioned here, 4 of them: public/permission, private/permission, public/permissionless, private/permissionless. But in regards to what you're going to specifically see is the different types of those particular technologies. And Hashgraph is definitely one key area. And Hedera's Hbar, or I should say Hashgraph, definitely brings something to the table unlike anything else. And of course, we'll have a particular breakdown from Dr. Lehman Baird. It's going to just blow your socks off, to say the least. At least it did for me. Now, of course, the most common one is what? Traditional blockchain technology, right? And of course, a lot of us know what that brings to the table and so on. But for the purposes of this particular video, we need to have a broader understanding of the Hashgraph. So before we kick it in right into this particular clip from Dr. Lehman Baird, I want to mention a few key things here. Multiple transactions can be stored on the ledger with the same timestamp in what? Hashgraph. A parallel structure is used to store all transactions. Every entry in the ledger is referred to as an event in this case. No node on the network will be able to manipulate the information or transactions in this distributed ledger without blockchain. That's a key thing here when it comes to understanding Hedera's Hashgraph. It means that no one on the DLT system can change or postpone all the instructions that would take place or control the transactions process. On top of that, when we compare it to the blockchain, we know that we can see how a miner decides which transactions to include in the quote-unquote block. The verifier nodes in the Hashgraph must include both your and the other user's transactions in the same order as you did, so no one is left behind. Kind of like basically what? Like Forrest Gump out in the middle of, Vietnam, not leaving anyone behind, but with what? A Hashgraph. I know it's kind of a literal weird representation, but think about it. It makes sense. So it says, what is different about Hashgraph? That's the main thing. That's why you're here, right? So let's get down to the nitty-gritty. All network transactions are provable in this type of DL implementation. As soon as transaction occurs on the network, everyone on the network will know where the transaction will be recorded in the ledger within a few minutes. And again, that's a key thing here when it comes to Hashgraph compared to other DLTs. Now, it says, furthermore, everyone on the network will be aware that the transaction has been detected by the entire network, allowing them to make the necessary changes. It indicates that the nodes will make the changes before discarding the transaction. This information will not have to be kept in your ledger indefinitely. As a result, the Hashgraph distributed ledger database platform only requires a few gigabytes of storage space to store all of its data. Now, there's a little bit more when it comes to the ACID nature of the Hashgraph network. You can read more about that, but for the purposes of this video, I want to go ahead and jump right into, for instance, this right here, because if anything, it's going to have a good outline before we get into what is mentioned about the gossip protocol. So let's hear what Dr. Lehman Baird has to outline when it comes to DLT. And of course, this is back in 2017. There was only 4 that existed at the time. Now there's 5. And of course, you know, as Web3 evolves, there could very well be 6 in the future, especially going further out and beyond that. So let's go ahead and kick it in to just that. Dr. Lehman Baird's old school lecture from 2017. Pretty interesting. And then we'll be right back.
Okay, so this is the history. You could say that the history of distributed ledgers has had 4 generations. Each one has built on the previous one, and then each of them continues to evolve over time. But we could say that what we started with, in some sense, you could say Bitcoin started with cryptocurrency, which was a really cool idea. We can have an actual money with no government creating it. That's a bizarre concept, and no one person can destroy it, and no one person's in control, and that's really cool. And so what we started with was cryptocurrency, and it was revolutionary. And so, of course, what you have to have is some way to put the transactions in order, and you have to be able to agree on it. And so there's some kind of a store of information that we're all agreeing on, and we're using it to store our cryptocurrency transactions. There's this ledger thing, but then we realize, well, you know what? It's just ones and zeros. We can store other things beyond that. So you could say the second generation is when we realized, well, we can do more than money with these ledgers. We could put anything in it. We could store all sorts of information. We could store ownership rights of property. And so I could have my money in it, and I could have the deed to my house in it. I could have all sorts of things stored in this thing. And so it expanded what you can do. Not only do I have money, I now have other things like property and identity and other interesting things can be built on top of that. But you know, this starts to raise an interesting question. If I can store my money in this thing, and you could store your house deed in this thing, wouldn't it be cool if we had some way to swap without having a third party? The problem, of course, is that if I email you my money, you might not email me the property. And if you email me the property, I might not email you the money. We need a third party to take them both and then swap them and then put them back. But we don't want to trust third parties. So what we could do is have some kind of a program that runs on top of it that does arbitrarily Turing-complete interesting things. And so, of course, we have smart contracts. And so it was natural when you had a cryptocurrency to realize, well, there are ones and zeros, we could build a ledger. And then once you have a ledger to realize, you know what, we could do smart contracts on top of this thing. Everybody who's running the ledger could be running these little programs, and then we could be swapping all these different things that are on the ledger atomically, and we could be running arbitrarily complex programs. And so once we have the ability to have money and to have assets, and now to be doing these swaps so I can sell you something and you buy it from me, the next obvious question is, could you have a whole group of sellers and a whole group of buyers? Could you create markets? This would be the 4th generation. Could we do something beyond just simple transactions between 2 people and have large markets where there's lots of buyers and lots of sellers, and that there's some kind of a matching system that matches people up, like a stock market or a real estate market or an eBay, where you have multiple buyers simultaneously and do it in real time. Of course, to do that, you have to start worrying about fairness of how we match it up. So in a stock market, if everybody's putting in their bids on this stock, and you put in your bid, and I put in mine just a little bit later than yours, it would be a disaster if I could bribe somebody and get mine before yours. And so for this 4th generation, what we need to have is fairness of ordering. We need to make sure that if you put yours into it before I do, that it's actually going to count as being before mine, and that it's hard for me to get everybody to say that I did it first when really you were doing it first, when you were reaching the community first. And so we would say that fairness of ordering is where it's really reflecting when these transactions reach the community. In fact, you could say that is the exact definition. We could say we're going to put a timestamp on each transaction, which is when it reached the majority of the community. And then we'll put them in order by those timestamps. And then it becomes very difficult for any one person, like a leader, in a leader-based system, to reorder them, or to put them in the order that they like, or to just leave one out. It becomes very resilient to that. So you could say that these are the 4 generations. Now, of course, they call the 4th one markets, because that's where fairness matters. It's multiple people, not just 2 people. It's a large group of people all interacting in a way that is fair. But of course, that 4th thing can involve things that aren't at all a stock market, like games. So the same thing is applying to games. If you want to be doing a video game, an MMO, you need to make sure that if you shoot me and I dodge, we have to figure out which one happened first. Because if you shot me first, you get a point. But if I dodged first, then you don't get a point. And so we have to worry about that. And we have to worry about people hacking the client on their computer to try to cheat to get an advantage in this way. So that's the 4 generations of DLTs. You could say a lot of this 4th one also needs high throughput, but really all 4 of the generations are looking for high throughput. And security is important for all 4. So that's sort of a history of DLTs.
All right, so now that we have a broader perspective of the different generations of DLT, let's take a moment to show you guys what is outlined here in regards to the gossip protocol. And if anything, it's exactly how it sounds. You know, think about it, gossip, or back in the days of middle school and high school, you know, how rumors are spread. It's basically spread through gossip. Literally, this is what it's all about. So listen to this. The gossip protocol is used by this distributed ledger system to relay all kinds of information, primarily about the transactions across the network. Each node on the network can send out information on a new transaction known as events and pre-sign. Every node will choose a neighboring node at random to relay this information to. A node will then combine the event with other received data before relaying it to nearby nodes. Now, when a transaction occurs, neighboring nodes share the information with other nodes. Think about it. It's like it says, it's gossip. Pretty funny, ain't it? But nonetheless, let's get more into it. It says, and after some time, all nodes are aware of the transaction. Because of the process is quick, everyone on the network would know about the event in a matter of minutes. I mean, if you think about it, I couldn't come up with a better name for this protocol than gossip. It literally is. So it says every node validates the transaction and then it adds it to the ledger using the virtual voting protocol, like basically what you're going to see outlined right here. So let's go ahead and jump into that specific part of this outline, and that is gossip. Back to Dr. Baird.
Let's talk about how this works. So Hashgraph can do the 4th generation stuff. It can do the fairness of the timestamps. The timestamp reflects when it reaches most of the people. Now, of course, if you can cut my computer off from the internet, it's going to take me a long time to reach everybody, and my timestamp will say that my transaction was very late. Okay, you could say, well, life's not fair in that way, but the timestamp is fair. The timestamp will still reflect when my transaction actually reached the community. Or if you have a faster internet connection than I do, then of course yours will reach the community faster. But the timestamp will be fair, it'll reflect that. So Hashgraph does all those things. Also, Hashgraph is fast. In some sense, it's kind of going at the limit of whatever bandwidth you have. And here's why. If we're going to build a ledger, we have to have these transactions spread out to everybody. Now, of course, we can go to multi-sharded systems. That's a good idea. But in order to have a fast multi-sharded system, you want the individual shards to be fast. And so let's talk about what goes on in a shard. Within it, every person has to receive every transaction. That's the bare minimum. We're going to have digital signatures. That's a bare minimum. And we're going to have timestamps. It would be very difficult to have a system with no timestamps at all and still get fair timestamps out of it. So this is kind of the bare number of, the minimum number of bytes that we're going to have to send over the internet. So you have to have enough bandwidth to receive each transaction once and to send each transaction once and to have signatures and to have these timestamps. That's the bare minimum that any system will need if we're going to have a replicated database of any kind. What is the fastest way to get that much information out? If that's all we're going to do, we don't even care about consensus, we don't care about ordering, we don't care about timestamps, all we care about is just getting the information out. What is the fastest and most resilient way to do that? And by resilient, I also mean let's worry about DDoS attacks. Could someone shut down one computer and stop us? That's the fear. So here's what we do. We do gossip. Alice has a message that's read here. She picks someone totally at random, and she gives it to Dave. Now 2 people have the message. Now Alice and Dave each pick somebody at random. Alice picks Gina, and Dave picks Bob, and now 4 people have it. And then each of them picks someone at random, and now 8 people have it, and then 16, and then 32, and it explodes outwards exponentially fast. If any one computer is down, still explodes outwards exponentially fast. Doesn't really hurt us. This is incredibly resilient. There's no one computer you can shut down. There's no bottleneck. It's not like we all have to funnel our messages through one person, that everybody gives their messages to one person and they distribute it out to everybody else. And it's about the simplest thing you can imagine. This is the simple brain dead, just do stuff random and it happens. So this is used everywhere. Lots of things. I mean, Bitcoin uses it for 2 different things. It's used everything for everywhere. This is the best way that you're going to get information out, and that's gossip. Then, of course, the question is, what happens if 2 people want to send a message out at the same time? Bob and Carol. So in a traditional database, distributed database, if you want an ACID database, we would have something like 2-phase commit. We would have locks. Or in a leader-based system, we'd have a leader that takes turns. Basically, we had ways of forcing them to take turns, where maybe Bob sends it out to everybody, and then when he's done, Carol can send it out to everybody, and then we know the order. But that's slow. They're having to take turns. What would be the fastest way to do it? Oh, well, it'd be this simple, stupid way of doing it. Just do it. Bob picks someone, Carol picks someone at the same time. Now 2 people have each of them. Then each of them picks someone. Now 4 people have each of them. Then each of them picks someone. Now 8 people have each of them. It just explodes outwards for both of them at the same time. Basically, with the internet, you're never going to get faster than this. This is as fast as you're going to do. And if all we're doing is spreading out our transactions with their signatures and their timestamps, this is the minimum number of bytes that we're ever going to be able to send over the internet. This is the baseline of what you have to do if you want a replicated information store of any kind. The problem, of course, is look at the order they received them. Bob received red, then green, then blue, but Alice got them in the opposite order, red, then blue, then green. So the stupid brain-dead way of doing it is really fast and resilient, but it doesn't give you a consensus on order. It also doesn't give you a consensus on timestamps. When did the community reach the get the red one? I don't know, everybody got it at a different time. That's not really a good way of putting fair timestamps. We could ask Alice, what timestamp did you put on your message, but she might lie. So this doesn't give you consensus on timestamps, it doesn't give you consensus on order, but it's incredibly fast and resilient way to get your stuff out. So then the question is, how do we get consensus? And the answer is, hold that question. We're going to do something else. We're sending out all this information in the most efficient way we know, and we're going to add one tiny little bit of extra information. When I talk to somebody and get all his information, and then I talk to you, I'm going to tell you the last message I received from him and the last message that I created. That's it, just 2 messages. Just pointers to 2 messages. So I'm going to have this big, long conversation with you. At the end, I'm going to create a big one of these messages, one of these events, and I'm going to include in it 2 hashes of 2 other messages, and that's it. This can be an incredibly tiny amount of information. In fact, there's ways you can compress these caches down just a couple of bytes, because it's a hash of something you already have in memory, and you don't have all that many things in memory. And so it's unique among, anyway, you can compress it a lot. So we're going to do that. So we've done the most efficient thing we can imagine. We're sending all these bytes over the internet, and then I'm adding, I don't know, 1% more bytes, a little bit extra. And that tells me nothing about consensus. Why did I do that? Here's why I did that. What we can do is draw a picture of how we talk to each other. So I'm imagining a world here of 3 people. We start at the bottom and go up. And what we say is, here is the event where Alice called up Bob and told him everything she knows. Here's the event where Carol called up Bob and told him everything she knows. And apparently Bob turned around and then talked to Carol and told her everything he knows. He also turned around and talked to Alice and told her everything he knows. And you can just follow up the graph. That is a history of how we have talked. Here's the magic thing. That thing about putting 2 hashes in every message, if they're referring to the last 2, the last one you created and the last one created by the last person you talked to, just by adding that tiny bit of information, you get this entire graph in memory. In fact, everybody does. Everybody gets the entire history of exactly how we talk to each other. In other words, we're not just gossiping about these messages that contain transactions. We're not just gossiping about messages that contain identity information or other types of information. We're going to gossip about this graph itself. We're gossiping about gossip. So the whole point of this graph is it's showing us the history of how we talked. And what did we talk about? This graph itself. We're talking about the fact that we've been talking about things, which is very strange. Gossip about gossip. But it didn't cost us very much at all. And what do we get? Every person has this graph in memory, and it's the same. Every person, any person who has this top event here, has the 2 hashes of these 2. Therefore, every person who has this one has exactly these 2. Every bit is the same. You can't, unless you can break the crypto system, the hash system, they must be guaranteed to be the same. And if you and I both have these, then you and I will both have their parents down here, and these 2. And so the whole graph has to be identical. So basically, if you have that one at the top and I have that one at the top, then we have exactly identical graphs below it, guaranteed. And what we have then is a history of how we've talked to each other. And so I know what you know. And I know when you learned it. And I know what you know about what Alice knows. And about when Alice learned those things, about what Bob knows. I can do really deep, complicated reasoning about what we know and when we knew it. I can do deep reasoning about our level of knowledge at every point in history. And I'm getting all of that information kind of for free. You know, I'm adding 1% to my bandwidth cost. That's it. Okay, that's cool. But what good does that do us?
All right, welcome back. So if anything, let's talk briefly about this right here. And that is, like it shows, DLT is a broad term that refers to digital database technology, which has a variety of implementations in the ecosystem. Blockchain is the most popular one among them, like we outlined at the beginning. DLT is made up of nodes on the underlying network that use various agreement processes to come to just that, a consensus. Dr. Lehman Baird is going to outline the importance of just that, the consensus, because like it shows right here, as a result, the DLT is not only digitized the entire ecosystem, but also provided fluidity, integrity, security, and decentralization. So let's go ahead and understand a little bit more in regards to just that consensus. Here we go.
We still haven't got to consensus. Now here's the magic part. I'm going to get consensus completely for free. At this point, I'm going to send 0 bytes over the internet, and I'll have consensus. Because I'm going to do virtual voting. Remember one of those earlier slides that said that the voting algorithms have these wonderful math properties? They are asynchronous, Byzantine, fault-tolerant. They are resilient. They are DDoS resilient. They can even, in some cases, have types of fairness, although fair ordering is far more difficult than fair yes-no questions. But they can have something like fairness in some cases. The voting algorithms are absolutely beautiful, and they predate all this stuff. They come before Bitcoin. They go back 30 years. These voting algorithms are fantastic, except for the slow problem that the voting algorithms have votes. And if there's 1,000 of us, and each of us is sending a vote to everyone else, that's 1 million votes going over the internet. And because you might be lying about your vote, we all have to tell each other what each other said, which means you now have 1 billion receipts going over the internet. And that's for one round. Then you have to have multiple rounds, so it's multiple billions. And that's just to decide a single yes-no question. Then we have to somehow decide a whole bunch of yes-no questions to put things in order. It's impractical. Huge bandwidth costs because we're sending billions of messages over the internet just for these votes and these receipts. But if I have a hash graph, I can do the voting purely in my head. I don't have to send any bytes at all over the internet for the voting part. All I do is I say, I know what you know, and I know when you knew it. And so if we were to run a voting algorithm, I know exactly how you would vote right now. So don't bother. There's no need for you to send me your vote. I know you would have voted yes on this question. So don't bother. I'll just pretend you've said yes, and I'll continue. And we can run the entire voting algorithm purely in our head. So that's virtual voting. So the Hashgraph consensus algorithm is gossip about gossip with virtual voting. And that's all there is to it. It's actually really simple. It's in some sense old-fashioned algorithms, voting algorithms that are wonderful, but with no votes. And we're doing it because we have a hash graph that shows us the whole history, but we got that almost for free by adding a tiny bit to the original thing. Oh yeah, and so what's inside of each of these? An event, one of these circles, has to remember the hash of the event that this line went down to, and the hash of the event that this line went down to. That's what it was supposed to say. And then, of course, you have transactions. Yeah, we do actually care about transactions. That was the whole point of this exercise. So when you create an event, if you have any transactions you want to create, just stuff them inside. That's it. They come along for the ride. They're just the payload. They just kind of ride along with the events. And then you have to have a timestamp and you have to sign it. But you would have had to do that anyway. So these top 3 levels are the bare minimum that you'd have to have just to have distributed object stores that everybody knows the same data. And these last 2 are the extra overhead for gossip about gossip. to get a hash graph. And then for the virtual voting, you send 0.
All right, now that we have an idea of how the hash graph works, let's jump into, for instance, what we have outlined for you guys in regards to the origins of just that, Hedera. So check this out, and this is from a particular site called Warda. I'm gonna try to blow it up just a little bit more for you guys. But look at this. It says Hedera and Hedera Hashgraph technology. The origins of Hedera date back all the way to 2012, when Dr. Lehman Baird first began developing his algorithmic model. That's one of the key things here. I mean, this guy is probably one of the smartest guys in the planet. At least that's how he impressed me. He aimed to find a revolutionary approach to scalability problems and find a golden middle in distributed consensus security. That doesn't sound impressive already, right? By the way, Baird was a professor of computer science at the United States Air Force Academy. Wow, think about that. And that's why I'm even that much more wanting to take a deep dive now into Constellation DAG, because we know about that particular Air Force connection. Be on the lookout for that. So he holds a PhD in computer science. He holds a PhD in, I just said that, computer science. Baird was also a co-founder and CTO of identity management companies, Trio Security and Blue Wave Security. For 4 years, he worked diligently on his brainchild, leading to the first technical documentation. This is not just like some average, run-of-the-mill project that just came out of thin air. Hedera's Hbar is so darn impressive that, when I look into the partnerships like NASA, Boeing, Boeing, LG, some of these other ones, I say to myself, Google, I say to myself, yeah, this makes sense. This totally makes sense, because they realize how smart this guy is and what Hashgraph brings to the table as far as just that, technology. Now, look at this. It says this document was published in 2016 and was called, listen to this, quote, Hashgraph Consensus. Great segue from where we just came from on that particular clip. It says fair, fast, Byzantine fault tolerance. From the title, it can be inferred that it tried to find a solution to the Byzantine fault tolerance. For example, Byzantine fault tolerance is a condition of a computer system, particularly distributed computing systems, where components may fail and there is imperfect information on whether a component has failed. Remember, in that particular lecture, he mentions that if some things fail, it's still okay. It's not going to shut down the whole darn system. Like basically Solana. Might as well throw that out there. The term takes its name from the allegory The Byzantine General's Problem, developed to describe a situation in which, in order to avoid catastrophic failure of the system's actors must agree on a concerted strategy, but some of these actors are unreliable. Thanks to the published scientific work, many experts view Hashgraph as the first technology that has managed to tackle basic blockchain problems. It's one of the key things you need to understand, at least I wanted to, at least. The system is closely tied to a high level of security, and can be said that the scalability of the project is at an appropriate level. In 2018, Lehman Baird finally publicly unveiled his project, which we now know under two names, Hedera and Hedera Hashgraph. However, not many people wonder what the key difference is. We will now explain. Before we get into that particular explanation, I want to show you guys this, and that is something recent that we promised that we would show you guys coverage from, for instance, Davos. Look at this. It says, quote, in a way, it was helpful that we had an implosion because the weaker entities fell down. She discusses, as in Nilmini Rubin, who is the Hedera Chief of Staff and Head of Global Policy, just that, how the blockchain industry can build back trust following the collapse of FTX. It's all about security. This is a minute, and we'll come right back.
People, especially in the wake of FTX, they want to be able to trust the blockchain and understand where the decisions are being made to run it.
How do we build trust in the industry as it stands now? I mean, we just had a massive implosion after implosion in 2022. So how do we establish trust in 2023?
Well, in a way, it was helpful that we had an implosion because the weaker entities kind of fell down. And you have the stronger players in blockchain and crypto coming up. And I think if we continue to act legitimately and securely, that we can build trust. If we communicate clearly about what we offer, we'll build trust. If we follow up on our actions, we'll build trust. But also, if we create governance that people understand, then we build trust.
So they are all about security, and if anything, they're also all about building just that, trust. And let's face it, I mean, when it comes to a lot of this, the average retail investor who heard all the bad mainstream news, there's not a lot of trust. You like the idea that Hedera is addressing just that, trust, security. Let's get back to answering this particular key difference. So it's just that Hedera plus Hashgraph equals Hedera Hashgraph, right? Well, question mark. It says the statement in the headline is correct on the one hand, but not quite on the other. Basically, we could say that Hedera Hashgraph is the name of the company. Hedera Hashgraph can also refer to the private management circle that runs the company, whereas Hashgraph is the name of the consensus algorithm that Dr. Lehman Baird worked on for many years. So you're talking about, for instance, a guy who not only invented this particular algorithm with Hashgraph, right? But if anything, built what we see in Hbar. So, think about how many different, blockchain projects there are out there, or just, crypto projects in general, where you have some guy, I hate to say it, where he has no experience. He claims he's a developer, and the project just has a vision of what could happen for the future. Talking about a guy who's literally invented a unique model from the ground up and is a professor in these particular fields. It's unbelievably impressive. All right, look, let's get into this. So, why should we consider Hashgraph? That's the bottom line, right? Well, of course, I'm not trying to sell you on anything, but I love being able to provide these particular deep dives for you guys because I think, if anything, you do appreciate it. At least most of you guys. Some people don't. Anyway, why consider Hashgraph? Well, security, transaction speed, scalability, and ACID, which is called ACID. No, not 1960s ACID.
Well, sometimes it never ends. Sometimes it never ends. Sometimes it never ends. Never ends. Never ends. Alan, sometimes it never ends. 5,000. Alan, 5,000 Michael. Alan, can you hear me?
So let's start off with security. So as you see right here, it mentions specifically Hashgraph uses asynchronous Byzantine fault tolerance, ABFT. Man, that was a mouthful, wasn't it? A type of BFT to secure data stored on the network. It can be said that this is one of the strongest degrees of protection presented within cryptography. That is a bold statement. Wow. Allowing much less worry about security. Now, in regards to transaction speed, I've heard it from a few guys from the community. Shout out to Cool Cat Crypto. He says that he's tested this and that Hashgraph, or on Hbar, is the fastest. And I believe him. He's got a lot of experience. Look at this, transaction speed. When it comes to speed, the Gossip protocol, like we outlined earlier, comes into the game. It can handle up to 10,000 transactions per second, with verification occurring instantaneously. A technical feature of the protocol is that the number of nodes in the network increases. They increase the effective processing power of the network. Basically, like a bunch, like Dr. Baird, outlined. You have a bunch of people gossiping. Hey, girl, did you hear about Mr. Gilbert Verdant? Yeah, girl, he was out doing this and that. And then that spreads. Hey girl, did you hear about Dr. Lehman Baird? Oh, I saw he was over at freaking Davos doing his thing. And then that spreads, and then that spreads, and then more people talk about it and so on. I know it's a weird representation, but come on, it's gossip. Hence what you see right here. All right. So yes, a technical feature of the protocol is that as the number of nodes in the network increases, they increase the effective processing power of the network. I know I read it twice. Scalability. Again, quant, they're always talking about scalability, right? Listen to this when it comes to Hashgraph. The aspect that Dr. Lehman Baird was working on, that's a typo. Or is it? I don't know. The asymmetric algorithm technology is much more scalable. The risk of bifurcations is greatly reduced. Now, acid. Yes, like I said, not that acid, this acid. Hashgraph is compatible with acid. Atomic, can you pronounce that right? Atomicity? I apologize. Consistently, isolation, longevity, a term that applies to databases and ensures data consistency. Now, here's the thing. When it comes to Hedera's Hashgraph, it isn't technically a blockchain. Hear me out. Like it says, it is not a blockchain. Once again, same fate. On the one hand, true, but on the other hand, not really. Hashgraph, as the developers claim, is a more efficient substitute for blockchain. In essence, they use a different way of signing blocks, whereas blockchain users, or I should say, uses a clear sequence. Hashgraph uses directed acyclic graph, which is DAG. The main difference lies in the type of block recording. To summarize briefly, we can outline Hedera with a quote from writer Rachel Hoffman. Yes, listen to this. States, quote, it's quite strange to look at the chaos and think, oh, there's clearly a perfectionist living here. But it's quite typical. Hedera really may look like chaos, and it does. When I first saw this, I'm going to scroll down here. I mean, blockchain just looks so uniformed and so proper. And then Hashgraph is just all over the place. But think about this. So is gossip. Gossip is all over the place. That's the gossip protocol. But you may think, well, that doesn't make a lot of sense. But again, if you listen to what Dr. Lehman Baird was saying, it makes perfect sense, especially with how he broke it down. So don't look at it from this particular tunnel vision if you just came in from this particular point in the video. You do got to watch what Dr. Baird says because it did make sense. So for instance, yes, Hedera's acyclic method promises all the benefits of blockchain, but excludes low transaction speeds. If we approach the question in the headline mathematically, we can quote a passage from the technical documentation. Asynchronous Byzantine error tolerance, man, I do not want to have to say that 20 times a day. Anyway, to put it simply, in order to affect a network, more than 2/3 of the network must agree, analogous to a 51% attack requesting more capacity to make changes. I gotta say this, I know this is kind of off kilter, but if you ever watched the Mike Tyson fight back in the day where he was just like, he get interviewed, he'd be like, yeah, man, I am Socronius Byzantine error tolerance. I want to scientifically and metamorphically, box him in the ring. He would always pull out all these darn words from the thesaurus, right? Mike Tyson, if you happen to be watching this, try to say this 4 times fast. Anyway, old school Mike Tyson. I know, a little off kilter. All right, gossip equals protocol. To circumvent the mining structure, Hashgraph uses consensus protocol based on virtual voting. Now, we already have this explained, but if anything, I want to bring your attention to this right here that was quoted in a particular study. It says, epidemic algorithms for a replicated database maintenance dated to 1987. This work is vital to the development of these algorithms, not only for Hashgraph, but also for other areas of computing. We're talking about a model that dates back to 1987. And you got to keep in mind, Dr. Lehman Baird has been working on this from the ground up, dating back what was it, 2012, 2014? Don't quote me on that. But obviously, when it comes to the original model, dates back to 1987. I mean, it's just really, really impressive to see the history of some of this, right? I'm not going to read all this particular here, but if anything, I want to show you this Hashgraph transaction cycle. Let's touch a little bit on this. I know this is a real long deep dive. If anything, I like to have a better perspective of all of it, what I'm investing in. I want to know all about it personally. So it says Hashgraph transaction cycle. For a more detailed understanding, the whole Hashgraph cycle needs to be deconstructed. Understandably, the process can seem quite complicated, so let's go step by step. Network members, nodes, exchange data using the Gossip protocol. We already outlined that. Hey girl, what's going on? It gets passed through the channels, and then channels and more and more and more and more. 16 becomes 32, 32 becomes 64, 64 becomes 128, 128 becomes 256, 256 channels become 512, 512 becomes 1078, 1078 becomes 2048, 2048 becomes 4,000. I don't know where we're at now. Anyway, nodes begin exchanging transaction data. By the way, in a blockchain network, all information on the network is exchanged along with the process. The information is not stored in blocks, but in hashes. This allows the data to be exchanged much faster. And again, they've proven that. Ultimately, transactions are recorded in chronological order, allowing them to be tracked down later. Let me track down the lady that did all this gossip. Think about it, literally. Who was the source? Wendy, I heard you talking about Bill down at, the Waffle House. Like, huh? What? That's not what I heard. I heard that Bill was down at IHOP. Well, kind of like the Waffle House. Anyway, I know it sounds crazy, but literally, Gossip protocol. That does make sense. I like Hedera. I want to use it. What should I do to begin with? Hedera offers the user 4 main services. Listen to this. A cryptocurrency service, duh, right? Smart contract service, that's good. Storage service, that's another area that sometimes is overlooked. And by the way, storage services are really, really starting to stand out. Consensus service, which in turn includes a timestamp cryptography service. All third-party applications built on Hedera have synchronous Byzantine fault tolerance. Darn phrase again. Hedera claims that Hashgraph can host stablecoins, financial markets, exchanges, even real-time games. Wow. Hedera can also be used to exchange encrypted messages using short-term private keys. Now, there's a little bit more in regards to the programming languages used by Hashgraph, such as Lisp. It's funny how I mentioned Mike Tyson earlier, no offense, and Java. The core is written in these two programming languages. However, it leans towards a JVM language such as Scala, Java, using the SDK offered by Hashgraph. Now, finally, conclusion. I will read this. Hashgraph is a really interesting concept that is able to shake up the market one day, and it is as we speak. How do we know that? Boom, here you go. It's up 17.5%. It was actually even up more than this. This particular price was in the 8s earlier yesterday. I think even Stardog outlined that to me. And I did state to you guys that after Davos or during or after, can't remember. I saw, for instance, Hedera's Hbar doing at least a 2x, and it did. It went from roughly 4.5 cents, or in the early 4s, to 8 cents. Not too shabby. A nice 2x. Let's jump back to this. But yeah, it says, for instance, it's shaking up the market one day. That day is here. It works much faster than traditional distributed ledger technology. And that's the key thing here. Like, for instance, we saw that it was faster than Visa. And of course, on the live show, we did outline that. However, it does have its flaws. While the lack of mining has a positive impact on network speeds, for many, it can be a discouraging factor, and the amount of criticism the cryptocurrency faces can have a very serious impact on its value. But let's face it, we know, for instance, if you have the likes of, whether you're a fan of it or not, the World Economic Forum officially recognizing it, it has leapfrogged itself, to say the least, because They only want to officially recognize those that they feel as though are pro-green. Think about what their initiative is, right? With the WEF. Because in terms of technology, mathematics, Hashgraph is a seamless infrastructure with a claim to ubiquitous use and solution to long-standing problems. In terms of value, the various speculations in the information field could shake the value of the token considerably. No one likes a competitor. Wow. All right. A little bit more in regards to this, okay? I saw this earlier today. It is at least, I gotta give you guys at least an update, okay? Other than just, these educational lectures. It says adopting Hedera Hashgraph as a security layer is cost effective, easy to implement, energy efficient, public, privacy enabled solution which can be adopted by institutions. Yeah, that's where I'm holding on to this long term, because that when that institutional money kicks in, it's gonna be something else. It says enterprises and individuals world over today, the likes of NASA, like I mentioned before, Standard Bank, IIT Madras, Shinhan Bank are already implementing the network within their own information technology environment, and even Reserve Bank of India in a recent working paper referred to the Hashgraph, listen to this, technology as a possible solution for all of their rotary, secure funds transfer and storage needs. All of it. That is bullish news, to say the least, right? So I was thinking to myself, well, all right, so that's just some random person posting this. Is it really true? You better bet your sweet aunt it's true. Here's the particular proposal summary. And look at where this comes from. You will see, for instance, right here, proposal title, Hedera Hashgraph based distributed ledger for aerospace applications. Does that sound like maybe it's connected to the likes of NASA? Yeah, absolutely. So we get further into this, and you see, for instance, it says that there's a clear problem that exists when teams of engineers are working to develop components of a complex system, from engine mounts to an entire electrical grid or a satellite, or they are managing a collage of resources that must function as a highly efficient ecosystem. They must be able to know with 100% certainty what's the correct version of a set of engineer drawings, or what the current functional capacity of distributed resources might be at any given time. They need one source of truth. Listen to this. The solution to these scenarios is in a technology that C10 Global is invested in, called Hedera Hashgraph. This is why I think, if anything, I hate to say it, like when it comes to the SEC, they look at this as like being insider trading or something like that. Because, I mean, these are the magic moments, if you will. And I will state this. When we get more regulatory clarity, some people state, well, that's going to be the end of the days of the Wild West in crypto. And yes, that's true. But once we do have more of that regulatory clarity when it comes to crypto, I get excited about, because then I realize when we complained about these particular prices, and there's people that are swing trading this as we speak, this is where, or I should say, when institutional money will come in. And once institutional money starts coming in to the likes of all this, doesn't matter if it's Hedera, Quant, you name it. Oh my gosh, that is literally being, at the level of the elites of the world, the 1% of the world. That's what excites me, is magic moments like you see right here. This is the aha moment for me. Hedera is a public distributed ledger technology, DLT. Yes, we outlined that at the beginning. That solves all of the challenges. Guys, this is not my words. Think about who's writing this. Challenges and inefficiencies of the blockchain commonly associated with Bitcoin and Ethereum. Thank you. If you're a Bitcoin maxi, you may want to understand that, because if anything, think about it. Yes, there's still going to be opportunity with Bitcoin. Don't get me wrong. It still go to 100,000 and up. Don't get me wrong on that. I just think as though altcoins are, if anything, 100x, 1000x. I know it sounds crazy, but if anything, I think Hedera's Hbar is at least 100x, if not more. All right. It says, unlike blockchain, Hedera Hashgraph provides for transaction speeds up to 500,000 per second. Who do you think is writing this? This is pretty impressive. With over 900,000 a day in beta phase, the highest known level of security. I am not saying that again. You guys already know what that is. I'm just going to call it ABFT. And a world-class governance council that includes Boeing, Google, and IBM, among others, and is invested managing members. You think the likes of those want to get into something that's a flash in the pan? No freaking way. No. C10 Global and its exceptional partners and advisors propose to meet the needs of, yeah, you already knew, NASA, and future commercial clients by developing a decentralized app that provides a trustworthy, robust, encrypted file service, decentralized app, and a space mission management. Man, can we get the RZA of the Wu-Tang Clan to bust out a rhyme just what we said right here? Anyway. Decentralized app built on Hedera Hashgraph distributed ledger network, providing enterprise level 1 performance, 2 security, 3 governance, 4 stability, 5 regulatory compliance. Again, can we just get somebody from the hip hop stop till you don't drop spitting out all this amazing stuff? Because it is pretty darn amazing. It's impressive to say the least. And look at this, potential NASA applications. It gives you all this particular outline. I like this particular part. The Space Mission Management D app will track and receive real-time status reports on key ground space and communication resources, providing a verifiable, decentralized source of, quote, truth for the management of those resources with maximum efficiency. Not partial efficiency, maximum efficiency. We're talking about NASA. And if anything, those guys need to have the most secure network of anything out there, right? You can't have somebody like out there floating out in orbit, or who knows, maybe going to the moon or space flight to Mars. I don't know. And basically, you know, your equipment fails or there's a hack or something like that. Has to be 100% maximally efficient. That's security, right? And of course, you know, there's potential non-NASA applications and so on. But guys, this was so impressive. I had to share it. I was like, wow, this is something else. And then how about this? All right, before we close this out, Hedera's Hbar. All right, it's technically higher than the market cap of Quant, just currently speaking. I mean, Quant, you know, they kind of hover around. But what's the key thing here? I want to show you guys before we kick it back into this. Here's the key thing. We talk about the ISOs here at Crypto Talk Now. Why do we talk about the ISOs so much, right? Here's why we talk about it so much. XRP, look at that, 41 cents is up. For instance, Cardano, you could technically count that in the future as being ISO 222 compliant. We'll talk more about Cardano in the future. Don't discount them. But if anything, I mean, I want to show you the consistency about some of these ISOs, right? And if anything, I mean, look at this right here. Stellar is up 6.52%. Don't seem like a lot, but the consistent thing is all these are like, still, you know, we're still so early. It's still not too late to get into some of these. You know, Hedera's Hbar, look at that. Quant, Algorand, see the consistency here? That's what I'm talking about. So if anything, I'm gonna kick it back to, for instance, Hedera, up 17.78%. Look at the volume, up 187%. I did state before on a few shows back that I guess, you know, after Davos, I felt as though it would, you know, do at least a 2x. It did. So I guess if you are the person that's swing trading it, you're more than happy. For me personally, this is not something I'm looking to swing trade. I'm keeping this long term. I'm blown away with Hedera's Hbar. And I'm more than glad to keep covering this and providing you guys updates, to say the least. They do have a verified market cap on CMC of 1.8 billion. You do have a circulating supply of 25,211,352,330 Hbar. 50% of the supply is in circulation. So, we'll keep up to date with this, and I will state this. I have a ton of Hbar content to share on the live show next time we have a live show, which is daily. So guys, it was more than great to be able to provide this particular deep dive into HBAR and the nitty gritty of how it works. If you appreciate these particular deep dives or just any content that we have from Crypto Talk Now, all I kindly ask is you simply hit the like. And if anything, if you're not subscribed, please subscribe. We appreciate it. If you like a live show, by all means, join us daily, 9 p.m. Eastern, 6 p.m. Pacific for Crypto Talk Now. And again, if you want more and more of this content, you want to be notified about it, hit the bell notification. May you all have a blessed day, everybody. We will see you on the next one.